today we're doing translations and reflections. Translations and reflections. So, Alex, not to mock your friend too much, but this is sort of an example of how people learn things and then somehow they don't quite understand them. But it's quite likely that if you showed your friend a graph question, they wouldn't understand it. Because maybe they didn't quite understand it when they first calculated.
But I'm assuming you need to know everything in pre-calc to do calculus.
This sort of thing, somebody who's doing calculus, it should be crucial actually. So that's why I'm really shocked. Okay, so translations and reflections. So remember, we have this thing, we have a function, and then we have associated to it, we have a graph, right? So this function is a rule, right? It's something that goes from, for us, it goes from the real numbers to the real numbers, right? And then over here we've got this thing called a graph, right? Where, x, y, let's call the graph gamma, okay? Function f with graph gamma. xy is on gamma means that y is f of x. And if y is f of x, then xy is on gamma. Okay, so translations and reflections, it's something pretty straightforward. So here's like the typical sort of thing that happens. Right? Let's say that this is the graph of f. This is the graph of f, right? And let's say that, so here's the graph of f again, and you have another graph that is the graph of g. Okay, graph of g. And you notice that the distance between these guys is 1. Okay. So the graph of g is exactly one unit shifted up. Okay. And the question is, what is the relation? What is the relation, or how does one express the relation between f and g? Okay. So just write down something in, what's the relation? And Alex, if you don't mind, I'll ask you to tell me what you think.
Well, if something's moved up one, does that mean you add plus 1 to the end of it?
Mm-hmm.
And then I know, I can't remember everything, but I know one shifts right and left and one shifts.
Don't remember, just look at it. Just look at it. You think, okay, well look, f takes x to a particular height. G takes x to that height plus 1. Right. So how do you express, what's the relation between f of x and g of x? Right. So fix x, right. Choose a particular x, and you see what's the relation? Well, what's the relation? G of x is?
G of x is up one response on the y-axis.
Mm-hmm. Right. So what does it say? That g of x is one more than
plus.
Right?
Or no, g of x is not f of x.
G of x is one higher than f of x.
Oh, okay.
G of x is, if I write it backwards, to make it more like English, G of x is, the alpha you get is one more than the alpha that f gives you.
Mm-hmm.
Right?
And that's, you can write it that way, right? It's not.
Yeah, I could have written it even there. A equals B, then B equals A. Okay. So this is what's called a translation. Okay. This is the data example. The first example is something called translation. right? If I have something below, of course, if h is below, then what's the relation between h and f? Julia? Subtract 1, right? So h of x is going to be f of x minus 1, right? It's going to be lower, right? If I have, here's f of x, and let's say that here is g of x. Okay? So f is this guy, g is this guy. Okay, so then let's say again that the distance is 1. What's the relation? What's the relation? Okay. How are they? How do you express this? How does 1 express this? Okay, 10 seconds and we'll count this. Caroline?
It's x minus 1 because you're going to the left on the x-axis, so it would be f of x minus 1.
F of x minus 1 is
G of x.
g of x. F of x minus 1 is g of x. Right? Let's think. Let me think about that. So if this is x, right? This is x minus 1.
Isn't it? Plus 1? Just say.
Is it plus 1? F of x plus 1 equals g of x.
Well, it moves to the G is moving to the left 1 unit on the x-axis, and so it's more negative than f is. Does that make sense?
Okay, I'm going to let you guys talk to each other for 1 minute and see what you think. So there are 2 possibilities, right? See, and then we'll vote. So talk to somebody next to you and see if you understand. See if you can puzzle out which one it is. Which one is it? It's one of these.
Yeah.
It is one of these.
First, we shift to the left.
So which one is it?
Minus 1.
Okay, let's vote. Okay. Who thinks it's this one?
This one, right? This one?
Okay. Who thinks it's the other one? 1, 2, 3, 4, 5, 6, 8, 8. And there are people who are abstaining, right? How many people did abstain?
Better be bringing it action people.
Okay. Okay, so.
I just want to remember, I can't give you any reason or.
Right. So you see, this is the trouble, right? You don't want to memorize, but rather you want to think about it, right? Rebecca, yeah?
Okay, do you want an explanation?
Yes, please.
Okay, the way I'm seeing it is that to get, because it's the same graph, they have to have the same values, but at different points.
Yeah.
So to get the same value at G as you would at F, you have to add 1 to X because it's moved.
So you're saying that,
Like, well, okay. Let me think. Now I can't, like, I can say it in my head. But
yeah, no, say, I think this is good practice, right? For you guys to try and talk it on, right? Go ahead, Rebecca. Try it. This is big. Pretend this is like a core class, right? And then everybody else will jump on you.
Oh.
Is that what happens?
No.
Okay,
So if you take a value of f of x,
Yeah.
okay, so say like f of x, f of 0 is like 1.
okay, so this guy is f of 0. So this height is f of 0.
Yeah.
Okay, and then you're saying that, oh look, g does the same thing.
So you want to get the same y value.
Yeah.
So it's like, it's -1.
at -1. So, you say
So, but you're
G-
not thinking of g of x, you're thinking of f of x.
Okay.
So, you're trying to think like, what value of f of x is it the same as g? So like, because everyone wants to think f of -1, but you're not trying to go, you're not trying to go like from f to g, you're trying to go from g to f.
You can go either way, actually. You
Well,
can-
yeah, but like,
How do you feel?
I feel like one would be lower.
So you're saying, we don't want to talk about f of x minus, you're saying we don't want to talk about f of x minus 1. That's
well,
what you-
because f of x minus 1 would be
Okay.
at which value is g.
Oh.
I don't know, you explain, you can do it, I bet you can.
Okay,
It's actually converted me because yeah, it's kind of tricky because then it's a lower x. So then if you do like -1, it'd be an even lower like y in the turnout. So then you want it to be the same, so you do the positive to make it the same y again.
so what are you saying?
Because with f of x, like if x is 1, and then we're shifting it one more,
Yeah,
then that would be like, let's say the function was plus x plus 1, right, or something, as an example. Then that would be like plus, yeah, it would be 0, yeah, that would be 0 at like f of x at negative, I like it would be at 1, whatever. I don't know this right. I just be perfect.
Try to.
I'm on an argument.
If the graph of f is 1 at 0, you want to find the value where it's 1 on g, and
Yes.
it's -1. So
Yes.
it would be g minus 1.
yeah. So you're saying,
It's like 0 is g minus 1, but
f
f,
at 0 is g and minus 1, right?
Yeah.
That's what you're saying. That's
so f
f at
like-
some general x
would be plus.
would be g, or g at some general point would be the same as f at
Plus 1.
x plus 1, or you could say the other way. F
Yeah.
at some point is the same as g at the time back.
Yeah.
So that's what so your argument was basically like, let's try a single point and see what makes sense, right? And look, for the general point, it'll be the same sort of thing, right? Which is good. That's one way of arguing. So yeah, and that is the right one. So the way I think about it is in terms of time, like whatever g is doing it 1 second ahead of time, right? G is doing it 1 second before f does it, right? When g attains a value, f will attain the same value, but 1 second later, right? G at time x will give you the value that f takes 1 second later, right? So I think that's a nice way of thinking about it. But certainly you can think about it graphically as Precalculus. And I always forget which way it goes, but then I have to remember. I have to figure it out using this way of thinking. Okay. Okay. So let me just put up a list of things that happen. Algebraically, let's say that g of x. Let's say that let c be some positive number, some constant. Let's say that g of x is f of x plus c. Right? Then in terms of the graph, then graphically, as we just said, this means that the graph of g will move up. Right? So translate f's c units up, right, to get g's graph. Right, so you take the graph of f and you move it up and you get g's graph, right? If I say g of x is f of x minus c, well, this means you translate the graph down, of course, right? As we just said, if g of x is f of x plus c, f of x plus c, which way is it going? Do I move the graph left or right? Left, right? Because G is doing things ahead of time, right? G is doing things before F does it, right? So this, we translate left, right? If it's G of X, G of X minus C, well then it's doing things later, right? So we translate to the right. If G of X is minus F of X, right? What does that say? Then the y coordinates
It's over the origin.
not the origin, but the right? All the y coordinates will be the negative, right? So you're flipping it vertically, right? You reflect the graph across the x-axis, right? And if G of X is f of negative x, then what happens? You flip it across the y, you reflect across the y-axis, right? Because you've reversed time basically, right? You reverse time around from starting from time 0. So whatever f does as you go forward in time is what G does as you go backwards in time, right? So it'll be a reflection. I think thinking of these things in terms of time is a pretty nice thing. Okay, so here's an example. Let's say that, let's consider the graph of x plus 3 halves quantity squared minus 1/4. And somebody says, draw the graph. Draw the graph of this. So maybe the way you want to think about this is to think about the graph of x squared, right? The graph of x squared, you know, right? Looks like this. The graph of x squared looks like this, and then what do we do? What do we do to it to get to here? Well, right, the first thing we do to it is, like if I didn't have this 1/4 line, what have we done? Okay.
Move it to the left.
We moved it to the left by 3 halves, right? We've sped up time by adding on 3 half seconds, right? So we go 1.5, right? And we shift it over here. Right? And then what's the second thing we do? Sure. We move it down by a quarter, right? Move it down by a quarter. Right, so we moved it across to negative 3 halves, right? We moved it over 3 halves units, and we moved it down 4 units. So, does everyone get that? Everyone see that from here? Okay. So, right. So, right. So we don't need to think about graphing this. We don't need to even, there's no work involved in graphing this as long as we understand translations, right? Translations and reflections, or just translations in this one. Okay. So for example, if somebody
Does it not matter? Oh, squared, it just makes it, you know that it's going to be sort of.
Right.
Yeah.
Right?
Yeah.
Is that what you're looking at?
Yeah.
It doesn't look like this.
I should have just not said.
Okay. Okay. So, for example, to make this example a little bit more relevant, if somebody gave you this, x squared plus 3x plus 2, and they said, what's the graph of this? Or they said, where's the minimum value of t? Okay. So, where is the minimum value obtained for this function, right? This is a problem that I said that, when you get to calculus, you get some tools that will enable you to answer this question for a wider class of functions, but we can actually do it for this sort of simple function in parabola. Right? You could do it this way. You could say, well, look, this x squared plus 3 halves, 3x plus 2, I can rewrite as x plus 3 halves squared, right? I added on a 3 halves squared, so I can subtract off 3 halves squared. Right? So I use the completing square. Okay? And I realize that this is this, which we just graphed. And now, using completing the square, we see that this is the thing. Yeah, no.
Could you explain how you went from 3 halves to 1 half?
Oh. It was a mistake.
Okay.
Is that why you're all scowling? Like, what are you? Go ahead.
Can you also factor it and then just find the I don't remember what it's called, the middle? And is that?
How?
Like if you were to factor it and find the x
Oh, yeah.
The
So if you found the two
zeros and
roots,
then find the middle of it.
that would do too. Yeah, but just to illustrate this reflection and translations. But that's what it works. So you can say, okay, you start up with some parabola, and somebody's asking where is the lowest value attained. You can do it by using completing the square and then recognizing that this is just a shift and another shift. It's just two shifts, right? And so you say, okay, the minimum value is attained where?
Yeah.
That okay, what you said it's at minus 1/4, or when I say where it's
on the
attained,
x,
like what
okay.
time?
Yeah.
Yeah. So
Negative 3 halves.
yeah, 3 halves is attained. The minimum value of a quarter minus 1/4 is attained at x equals minus 3 halves.
Why did you bother completing the square?
So that I could use the graph, and just work down. So really, this problem,
Can't you just look at the graph though and then figure that out? Why? I just don't understand why you added that step.
do you know that this is the same thing as this automatically?
No.
No, right? So
Oh, I see. So if you're gonna be equated like that.
yeah, somebody gives you this and says, where is the minimum value? Well, you complete the square. You recognize this thing is a double translation of the graph of x squared, right? Of the function f equals x squared, and then say, okay, well that's where it is. Is everyone all right with that? Okay, so this is a simple example of finding the minimum. And you could do it graphically. Another way you could do it is by looking at this thing here. Okay, look at this thing. What do you know about something squared? A number squared. What could it be? Could be negative. If you have some number and you square it, can you get a negative number?
Oh, wait.
Like I put a negative number, I square it,
Oh,
you get a positive number, right? Okay, so this square guy is either 0 or above, right? This square guy is at 0 or above. Okay. So we know that, so where could this thing be smallest? This thing is going to be smallest when this thing is 0, right? This thing is going to be smallest. To think about it, maybe more analytically rather than graphically. You say, well, look, this thing is smallest, right? So this is smallest when x equals 3 halves is 0, right? In other words, when x is minus 3 halves. Okay. you don't want to think about translations, and maybe you're blind, okay? You don't want to think about it graphically. Like there are some, there are mathematicians who are completely blind. I know at least one. Like you don't have to be sighted to be a mathematician. There's for your amusement, look at online this thing called Alexander's horned sphere. It is a like really crazy looking construction that was devised by a blind mathematician. It's a counterexample to this something that I forgot. Sorry, it's been a long time. Any questions? Questions? Okay, so let me give you a bunch of questions. So here's the question. It's like a seeing the relation question. Okay, so you start off with the function. This is problem 36 in the text. You start off with the function. F of x is negative x cubed plus 3x squared minus 3x plus 1. Okay, and they give you a function g of x is negative x cubed plus 3x squared minus 3x minus 1, and they say express it in terms of f. So this first one is pretty straightforward. What is it? It's f. What's the difference between this guy and that guy? Well, this guy is what?
So the difference in the y is 2.
Right. So this guy is just that guy minus 2. Right? And so we know its graph is just a graph shifted down by 2. Okay, so I'm going to put up a few more and let you think about them. For b, g is going to be x cubed plus 3x squared plus 3x plus 1. For c, g is going to be minus x cubed minus 3x squared plus 3x minus 1. And for d, you get g of x is minus x cubed minus 3x squared minus 3x minus 1. Let's just do a couple of them first. What about this one? What's B? Okay, you guys are bad at speaking. You should be proud of that. It's not a criticism. Sophie, 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 Sophie.
I'm still looking at it, actually.
Okay, well, let's look. So g of x, f of x is, look, oh, I see. So f of x is negative x cubed plus 3x squared minus 3x. G of x is x cubed plus 3x squared plus 3x plus 1. Okay. You see that something funny has happened, right? The minus signs on the odd terms
Yeah.
have all become positive.
So that means that it's reflected, reflected on the y.
Yeah, that's right. That's right. So, right, g of x actually is f of negative x. Right, if you think about it, look, if we put in negative x into these guys, right, what's f of negative x? Right, f of negative x is negative x cubed plus 3 negative x squared minus 3 negative x plus 1. Right, and you see that the odd terms, out will come a negative sign. Right, so here, for the even terms, nothing happens to them. Right. Right. So you have to sort of recognize there was a pattern going on, right? That the ones that changed, was there anything common about the ones that changed? Well, they were all odd counters. Right? The ones that didn't change were even counters. Okay, so this is like recognizing a pattern of behavior. Okay. Okay. What about this one? I think this one is pretty straightforward, right? Somebody want to tell me about this one? Yeah.
So then that one's just like negative fx.
Negative f of x, right? Yeah. Just everything got a negative sign on it. Yeah, Lauren.
Wait, what about g also minus 2 though, because the original f of x is plus 1?
No, because if we put minus signs on this guy, then, right? Negative, yeah, right. The minus sign will go on everything. Right? This will change plus, minus, plus, minus, plus, minus, plus, minus. Okay. What about the last one? This guy was f of negative x. Right? The last one is the most tricky one, although I wouldn't call it too tricky. Anyone get the last one? Alexa?
Is it negative f of negative x?
Yeah, negative f of negative x. So the graph would be that you flipped it across the, you flipped the time, and you flipped it across the y, and you've also flipped it across the, after that you flipped it across the x. Yeah.
Is it also, oh, wait, no.
Mhm.
Sorry.
Right. Okay, right? And so, you're looking at this guy and you think, oh, look, it's all negatives, right? You've got all negatives on the terms. And then maybe you remember that in part B, we saw the positives, and so this one's just a negative with that. Any questions? Let me do one that's a little bit more complicated. Okay. So somebody starts you off with g of x is the square root of x, right? Okay, so it looks like this. After the parabola flipped. Okay, and they say look at this thing. Okay, so what's the graph of this thing? maybe I'll let you think about it for a minute or so. Okay, maybe turn to somebody next to you and see what you do.
Well, and then she does it like down. This is very long. Yeah, I don't know. How are you doing? Yeah. But no, I can't see that. It's under the radical. It was outside the radical. It was outside the radical. Square root of negative except plus 2 is negative. No, it's up to now. I mean, it's like, yeah. I don't think, yeah.
Okay, so would people like to make guesses on what it is?
So it's negative x is reflected on the y-axis,
Okay, so you reflect it.
and then plus 2 means that there's 2 to the left.
And there's 2 to the left. Okay, so here is saying negative 2. Does anyone else have a different answer? Or is that what everybody got? Okay.
I'm not for sure it's, well, I'm pretty sure it's going this way and going this way, but I don't know what happened with the 2, because if it was outside of the radical, I know it would be shifted, but I don't know what's going on now.
Right. So the same question, right? So what's with this 2? Like, how do you think about this? How do you think about this 2, right? Because your time is backwards, right? Sophia, how?
I think about it as sort of being part of x, because if you were to, you would write it as like in parentheses. So that's how it got under the radical, essentially. Like it's part of x. If that makes any sense.
So you're saying that
It's, okay, it doesn't make any sense. So then you put it inside the parentheses of g of x, and that puts it under the radical because it's part of the x value.
okay. So let me say it like this. Maybe what you're saying, that this is sort of like g of x plus, no, sorry, g of x minus 2, but then you flip timeline it, something like that? Or, I'm not sure.
No, I mean, the question was like,
How do you know
get
what to do with this
under
thing?
the radical, or like,
Oh, no, it's sort of like, I think the question is, how do you know what this 2 means, right? How do you know what to do? What does this 2 tell you about how the graph is moved?
it's, you know that it's moving on the x-axis because it's part of, this is just how it works in my brain.
Yeah, Lauren.
Okay, so I think.
So this, this is the trouble, right? How do you explain something? It makes sense to you inside your brain, but how do you explain it to somebody else? You say, that's how it is inside my brain.
Well, it's telepathy now.
Yeah, if only.
I'm feeling it closer, I'm feeling it.
I sometimes try to have like psychic competitions with my daughter. Like she doesn't want to do something, and I want her to do something, and so we kind of. Lauren, yes.
Okay, well, I was thinking about it like the last one we did, where it was squared.
Yeah.
And you don't actually like square the 3 halves that we had, but you know it's part of what happens to x because it's within, like, it's the same thing that happens to x is what's happening to 2. So if it was like outside, it would be the square root, it would be what's happening to y, but because it's under the radical, if the same thing is happening to x, it's happening to 2. So it's like x.
It's silly,
So
Okay, you have to listen.
what I was trying to say is that like by like it's part of x is that it's happening directly. This is not going to make any sense. It's happening directly to x, like it's modifying the x value rather than the.
So it's certainly going to be a left-right motion, right? It's certainly going to be a left-right motion, for sure. Right, but I think Kate's question is, how do you know which way it's going? Right. Is that your question? Because you're saying, I think you said, if it were outside, I know what it would go up.
Yeah.
Right. But, yeah, but,
Okay, well, you need to think about it, like if you just saw negative x plus 2, would you know what to do?
Yeah.
Yeah, so the root is just to show the shape of the graph. It's not in effect to the translation. So if you were to take out the root, because the root is just showing you that it's half of a parabola, then you would know what to do because it would look like a normal formula. It would be negative x plus 2, so you would move it left 2.
That's sort of like the way of explaining that.
that's great. That's great. I'm not even sure I'm going to try to explain it any other way.
Hey, so forget about radical.
Well,
Until you get
Okay. Should I? So I have a way of thinking about it. I don't know if it'll. The trouble is that I like Becca's way a lot. I'll just sort of sketch out the way I think about it. Okay. So I think of this in 2 steps actually. I think like this. I think, okay, well, if I make like an intermediate function, h of x is root of negative x. Okay. Then that guy, I know what he is, right? It's just reversing the time. Here's h. This is f, that's h, right? But f of x is not that, right? It's rather h of x minus 2, right? H of x minus 2 is the square root of negative x minus 2, right? Right. That's our f, right? Negative x plus 2, that's our f, right? And so, right, if you take this guy's graph, right, and then you move it over by 2, then you get that. Then you get the graph of f. So that's all. But I like that this way better. Okay, that's it for today. Yes.